Hi everyone, thank you for joining the presentation today. My name is KLeC and I'm a silage microbiologist based at Rothamsted Research Northwick site and I'm going to talk to you today on maximising the value of your silage. I work on silage losses and also on optimum ensiling of multi-species swards. And I've been looking into the effect of dry matter and also inoculant on these during my time at Northwick. Making high quality silage is really important to ensure that the maximum nutrition is delivered to livestock and also that the hygienic quality of that silage is good. So what I'm going to do today is focus on the practical aspects of making silage, and I hope that this will give you a few things to think about and that we can have a good discussion during the workshop on the 27th of April. I've put my email address on this first slide, and if you would like to, please feel free to email me with your questions or comments ahead of the workshop, and I can make sure that we cover those, and I'm more than happy to do that. In the UK, 50 million tonnes of silage are made each year, and it's estimated that on an average farm, 25% of the silage is wasted due to dry matter losses that occur all the way through from the field, fermentation or during feed out. And we know that these losses can occur as visible or invisible losses. And the visible losses generally equate to those that occur due to forage that's not physically making it into the clamp. And you can see here that sometimes the trailer placement isn't good, or forage gets left in the field. Or it could also occur from silage that's thrown away before or after feeding, for example top spoilage or feed that gets rejected in the feed passage. The invisible losses are much harder to detect because they represent the breakdown of the nutritional components of the forage, mainly measured in sugar and protein. These again can occur all the way from the field through to feed out. And in the field they generally occur as plant respiration and breakdown of those nutrients as soon as the grass is mown. In the clamp they can occur due to respiration but also microbial activity when there's oxygen present, and also due to fermentation inefficiency. And they can also occur at feed out where yeasts and moulds cause aerobic spoilage, and this is generally detected either through heating and heating of the clamp, or where you can see visible yeasts and moulds causing that spoilage. So a quick note on heating, just to start with. Here I've been measuring the temperature of clamps at 3 different depths. So there's 3 different temperatures taken with 3 different thermometers here. The first, the yellow one, is a surface thermometer which is reading 15.6 Celsius. The second, the white one, is 15 centimetre depth, and the black and green one has a 50 centimetre probe. And you can see that these 3 thermometers all are reading different temperatures. The surface is the coolest at 15.6 degrees, 15 centimetres is 37.5 degrees, and then the 50 centimetre is 28.5. And what we can see here is a really classic example of aerobic spoilage. So in this clamp there is oxygen penetrating into the front of the clamp, and it's causing, it's enabling oxygen to be utilised by yeasts and moulds, and they're breaking down the silage, and that causes the heating that we see here. So at 50 centimetres the oxygen penetration is the least, and that's why that temperature is lower than the 15 centimetre probe. At 15 centimetres we see increased activity because the oxygen penetration is higher because it's towards the front of the clamp. And on the surface, although you would expect the most oxygen there, it's actually only reading at about 15 degrees because the heat is dissipating and disappearing into the air at the front of the clamp. So if you are measuring heating, it's always worth measuring at different depths to get the full picture of what's happening on that clamp face. And it's important to take readings at different areas. So you would normally expect for the density to be highest in the middle at the bottom of the clamp compared to the edges. So you can do comparisons over the clamp face and determine the extent of the heating problem that you have. There has been some published work on loss calculation by a group based in Italy. So I presented this figure from that work here by Boreani 2018. And what they did here is they've looked at 4 different silage management scenarios, and they've used data from a number of studies to estimate the percentage dry matter losses that occur at each stage of silage making. So the management scenarios that they've looked at are a good management, a not so good management, without any covering, and also a scenario where rain occurs during the wilting process. And they've split it into different stages of silage making from the field through to feed out. So what you can see here is in a scenario of a not so good management, you actually they predict that you could lose 57% losses under that scenario, and under good management this is compared to 13%. So by changing management practices, there is potential to really reduce losses and increase the nutritional quality of your silage. So I'm going to go through each of those stages and talk about the different management points that you could make decisions on and things that can make an impact on the quality of your silage. So wilting is one of the areas where you can reduce dry matter losses. And during this time in the field, while wilting, moisture is being lost from the crop, and this is really important in order to optimise the fermentation conditions that are going to occur in the clamp, but also reduce the losses that are going to occur through effluent if you put forage into the clamp that's too wet. We would recommend that your target dry matter is 32% coming into the clamp, and this is important to enable that optimum fermentation. If the forage is too dry, fermentation can be restricted. If it's too wet, you've got an increased risk of undesirable bacteria surviving through the fermentation, and this can jeopardise the hygienic quality of the silage, and it increases the risk of illness in livestock, and it can also reduce intake. So getting that right is really, really important. And I think one of the decisions that you could use to help you manage wilting is considering the order that you mow or pick up, particularly in relation to either how exposed the particular fields are that you're using, or the yield of the crop, because we know that if you've got a lighter crop, that will wilt more quickly than a heavier crop. So you can mow the heavier crop earlier in order to be hitting the 32% dry matter on all of your fields at the same time for pickup. And I would just like to direct you to the AHDB website, where you can calculate the dry matter of your forage using a microwave, and you could do this. You could do this after mowing to determine the starting dry matter of your crop, and use that as a tool to help you make decisions about when to pick up. So on this slide, I'm going to talk to you about an experiment that I did last year. And what we've got is the percentage dry matter of forage in the field after mowing. And what I've done is I've taken samples at intervals during the wilting process, and I've looked at the dry matter changes over that time. Now in this graph, the 3 different coloured lines are 3 different sward types, and the crop was cut at 9:30 a.m. On the first day, and what you can see from this is that the crop is actually not that far off target dry matter when it was cut. So it is important to have an idea of the dry matter of your crop in the field, and this can help you to manage those decisions. I took samples again 4 hours later at 1:30 and then at 5:30, and then 24 hours later at 9:30 in the morning again, and then at 1:30 the next day. And what you can see is that the crop rapidly wilts between 9:30 and 5:30, and it very quickly exceeds the dry matter target that we mentioned on the previous slide. But the main thing I wanted to highlight is that overnight there is very little change in the dry matter of the crop. It still wilts a little more, but not a significant amount. So this is an example of a time where, if you know the dry matter of the crop in the field, you can adjust the wilt time to ensure that you maximise the retention of nutrients in that forage. Because although it's not wilting very quickly overnight, all of those aerobic processes that result in the loss and the breakdown of nutrients is still occurring. So, for example, although you're not getting any benefit of loss of dry matter, you're losing nutrients during that time. So this is an example of a crop that you would be able to pick up actually quite soon after cutting and not leave it out overnight. So that's why it's important to not have a target time for wilting, but have a target dry matter, and try and stick to that. So we've started by talking about wilting and discussed the 32% dry matter target and how you might adjust your cutting time or management, for example, tedding, to increase the wilt speed. There are other areas where you can reduce losses. For example, in the clamp, the speed of filling should be optimum to ensure that the compaction and consolidation can occur properly during this process. So you would ideally ask your driver on the pit to be consolidating layers of about 15 centimetres and aiming for an end density of 750 kilograms per metre cubed. It's important to use a side sheet to reduce losses, and also seal the clamp as soon as possible after it's filled, even if it means asking people to stay on for a bit longer and making sure that the edges of the clamp have been sealed using gravel bags. When the clamp's open during feed out, it's really important to keep the face clean and to cut back the sheet regularly, and also consider the speed of feed out. So it's important to use a shear grab and not a loader bucket to feed out, and this helps you to keep that face clean. And that means that if you need to get across the face a bit faster because you've got some aerobic spoilage occurring, you can take half depth blocks in order to clear the face. If your feed out speed is quite slow, it actually might be important to consider making silage in bales, because then you can control the opening of bales as you need. So, in conclusion, it's really important to consider where there might be losses in your system. And there are management factors that will affect silage quality that are individual to each farm that will influence these decisions. If I had to pick top 3 areas to focus on, it would be wilting, sealing, and feed out. And I've just put a link here to the AHDB website because they have a wealth of resources that can help you to make these decisions. Thank you so much for your time, and as I said at the beginning, please feel free to email me any questions ahead of the workshop. And I'm just going to leave you with a quote that somebody told me, and that is that good quality silage has a higher value than poor quality silage, but they cost the same to make. So it's really important to think about that when planning and executing your silage. Thank you very much, and I will see you on the 27th.